Good morning. Welcome to AP Physics with Mr. Concannon. Today we'll be looking at the solution for the net force problem. As you can see, I've got a drawing up here. It comes from our problem. We have a table set up, a pulley on opposite ends, and two masses hanging from it. The details of the problem state that the two blocks, your hanging masses, are connected by a massless string. Massless means you don't worry about it. It's there holding them together, but you don't care about the mass. You also have two massless, frictionless pulleys. Again, massless, don't worry about the mass of the pulleys. Frictionless, they aren't slowing it down. They aren't providing any friction. You have the masses. M2 is greater than M1. And the system is initially at rest. First part of our problem asks you to draw a free body diagram. It wants you to label the forces to scale for each block. Now look at the diagram, how you have your objects hanging there, and think about what you would want to do. Okay, enough think time? Okay, first off, forces acting on both blocks. We have string, and they're hanging, so we have gravity. All right, so let's look at the string forces first. This block, they're going up. This block, they're going up as well. Same string, same force. So put in an arrow for each of them. Same length. That indicates the forces are equal. Now, no numbers were asked for in this problem. You don't have to come up with any exact values. Just make sure that representationally they're the same length. Now, let's look at the gravity. Are they both the same? No. M2 has greater mass. Greater mass means greater weight. Remember, weight, mass times gravity. So it's going to be a slightly longer arrow. M1, a little bit shorter. Now in both cases, the arrows will be a little longer than your tension, but down here, your M2 arrow should be the longest, M1 shorter. That's all that's asked for in this part of the problem. No numbers need to be attached to it, nothing else. Doesn't even ask you to label which force is which. All it asks is that you show that they are different. Part B of this problem. Okay, derive the acceleration on M2 in terms of M1, M2, and gravity. Okay, what that screams to you, net force problem. Remember, there's your symbol for net force, the Greek letter sigma. Sigma F, net, means the net force. So first thing we need to do, come up with the direction. Oh, the direction fairy's already told us. Positive will be that way. Why did we choose that? Remember, mass 2 was heavier. Do you have to use that? No. Use the other way, you just come out with a negative answer. Now, let's try and get our forces figured out here. Okay, M1, we'll start at the far side and work our way around. Okay, M1 is hanging down, but that would be negative, so you're going to have a negative M1 times gravity, that's the force of gravity on that. The tension goes up in the positive direction, plus tension, like that. Go to the other side. Tension's going the other way this time. So now you subtract it. And your M2 is hanging down, so that takes care of the physical side you have to start with. Let's look at the other side. Okay? The other side has to equal MA, all the M's. So it's M1 plus M2. Now, this time it's times A, not G. Remember, A and G are two separate things. Once before we've discussed that A can never exceed G. It could be equal to it, but it can't exceed G in these kind of problems. Okay? So it's still an acceleration, but possibly different from gravity. All right, now, we have our net force. The equation looks like this. Remember, you were asked to solve for A. A, all by itself. This is what you want to get. So you're back to equation rearranging. Time to go in there, work things out. Now, if you can see, your tensions go out. So don't worry about it. Let's bring these two down. M2G minus M1G. That's all you have on that side. It's going to equal M1 plus M2 times A on this side. Now, if you want to be neat, you want to cross all your T's, dot all your I's, not necessary, but now you can just change this a little bit. Bring your G out here, then divide both sides by this. And that's going to equal A. Remember, you just divide this out. Both sides, and you come up with this. So your final solution looks just like that. So, in summary, first step, net force problem, pick a direction that's positive. Any direction you want. Direction of motion, obviously. Pick it as positive. Always calculate your summation of forces equal MA. Account for all the forces acting on the object along the line of motion. Solve for whatever they ask for. Almost always it's going to be that acceleration. Okay? And finally, make sure you're neat. Always be neat. Neatness helps. Neatness will allow the person who's grading it to understand what you're doing, and it'll allow you to step through it a lot easier than trying to guess what everything was. Hope that helps you. Any further questions, you can just ask me in class. Boom.